there everyone, this is my construction cost estimate template. And we have the earthworks. Earthworks are engineering works created through the processing of parts of the earth's surface involving the quantities of soil or unformed rocks. So we have the different sizes and different forms of footing, tie-beam, and slab. So our earthwork is composed of clearing and grabbing, footing, tie-beam, and ground floor, slab, or gravel bedding. So for the size of our footing one, we have the 7, we have 5 for our width, and for our height we have 1, and the quantity is we have 7. And for our tie beam, we have 0.8, 0.3, and 5. And for our slab, we have 35, 0.7, and 0.3. So let's discuss further what's inside in the clearing and grabbing. So first, the number of items. Next, we have the length and the width. And how to get the total, we have times the total by the number of items, the length, and the width in order to get the total, which is the 1,440 square meters. For our footing, we have the length of 7.3 and the width of 5.3 and the height of 1. And to get the footing volume, we times the length, the width, and the height in order to get the footing volume. And we input the quantity of footing. We have 7. And in order to get the total volume of the footing, we have times the footing volume and the quantity of footing in order to get the total volume of the footing. And for our footing factor, we have 1.2. In order to get the volume factor, we have multiplied the total volume of the footing and the footing factor in order to get the factor volume. And so on for the footing 2, footing 3, and footing 4. And for tie beam, we have the length of 1.1 and the width of 0.3, height of 5. And to get the tie beam volume, we have multiplied the length times width times height. And we have the quantity of 6. In order to get the total volume of the tie beam, we have multiplied the tie beam volume and the quantity to get the total volume of the tie beam. And we have the tie beam factor, which is 1.2, and the volume factor, which composes of total volume of tie beam times tie beam factor, and produces the volume factor total of 11.88. For backfill, for the tie beam, and so on and so forth, for the tie beam 2, tie beam 3, and tie beam 4. For our backfill, we have the footing 1, footing 2, and footing 3. We have different sizes of it, different length, different height, different and length. Yet to get the volume, we have multiply the length and width and height. And we have the quantity 7. To get the volume total, we multiply the volume and the quantity. And we don't have the factor for our footing. So let's proceed to our tie beam 1, 2, 3, and 4. So to get the volume of the tie beam, we have multiplied the length times width and times height. And we have the quantity of 6. And to get the total volume, we multiply the volume and the quantity and can get the total volume. And for the last one, the total of or the sum of everything mm, sum of everything and the factor of 1.2 can get the 11,559.42. Yes. And for our gravel bedding, we have the footing 1, footing 2, footing 3, and footing 4, and the different sizes of it. We have 7, 5, 0.5. And to get the volume, we have multiplied the times the length, width, and height. We have the quantity of 7 and the volume. Total is composed of volume and the quantity. The factor is 1.2 and the volume factor is 1 is composed of volume, total, and factor. And it produces the volume factor. And this is where we input the data and the total and the result we have created is we have declaring and grabbing 1,440 square meters. We have the total quantity excavation of footing 1,901.44 cubic meter. Total of the quantity of excavation of tie beam we have 849.12 cubic meter. Total quantity of backfill we have 11,559.42 cubic meters. And the total quantity of the gravel bedding footing and the ground floor slab we have 425.28 cubic meters. So for our formworks, formworks is a term given to either temporary or permanent molds into which concrete or similar materials are poured. For formworks, we have the quantity reference in the book, and I based this template to Engineer Roland John R. Kahela. So we input we input the column height and numbers of columns, and we enter the length of the beam and the number of beams and the total area, floor area. And we can get the total height of 30 and total beam length is 21.00 and 30 for our column height. And then the lumber sizes can get 30 times 4.7, which is the standard size of the lumber scaffolding. For horizontal, we have 30 for our column only. 30, so we times the 30 for our column only. 30 times 21.00 for our column for our horizontal. For our brace, we have multiplied the 30 to the minimum size of lumber, which is 11.70 in 2 inches by 2 inches lumber size. And for our beam, we have multiplied the vertical to 21 times 4 for the vertical, and for our horizontal, we multiply the total beam length and the horizontal 4.70, and for the flooring, we multiply the floor area times 6.1 by board feet. Yeah. So you can enter the total number of board feet of lumber required. have 224.4 board feet. We have W1, 2, W2 have 4, and for the L we have 8. So the total number of lumber we have 43.00 pieces, and the total of CW nails we have 22 kilos. So for our forms, we input the height, column height, dimension of A, dimension of B in meters, and enter of numbers of columns, and get the result of result result get the result of total number we have 63.00 pieces, and total number of plywood required is 9.00 sheets, and total number of 2 1/2 CW nails we have 2.10 kilogram. Total number of number 1 finishing nails is 0.90 kilogram. And let's proceed to our masonry. This is created by our teacher, engineer Yuri Sisikan. Thank you, sir. And let's proceed to the plain and reinforced concrete. So we have this quantity reference. So for word spacing, we have 40, 60, and 80. Length of the vertical reinforced per square meter, we have 2.23 for our 40 and 2 layers. And the length of the horizontal reinforced square meters is 3.300. For 60, we have 2.13, 3 layers, and 2.150. For our 80, we have 1.6, 4 layers, and 1.70. We input our data in here. So we enter the wall height, the wall length, and the wall opening, and enter the constant factor for the vertical, which is 2.13, and the horizontal, which is 2,150. And result, we got the total wall area is 33.32, and the vertical bars used is 12.00 pieces at 6 meters. The number of bar used 12 pieces at 6 meters, and the tie wire used is 1.60 kilos. So for our ceiling, we have the quantity reference. The lumber size in inches is 1 times 2, 2 times 2, 2 times 3, and 2 times 4. For the spacing in centimeters, center to center, have 30 by 30, which is 4 in 1 times 2 is 4.103, and so on and so forth. This is different sizes of our spacing. This is different spacing for our lumber sizes. So let's input our data in here. To enter the length of the wall or ceiling or the flooring, we have 9 meters. Enter the wall of the flooring, we have 3 meters. Enter the constant factor, which is 0.89, and he uses 2 times 3. We have to enter the total board feet, 186.25, dimension of 2, 3, and 8. So the results, we have the number of board feet of studs and nail joint used is 162.25, and it composes of these three to get the studs and nailing joints. And for our lumber on pieces or lengths, you can get this through round up one total board feet over the tree, and can get the number of pieces, lumber in pieces. So for using 1/4 ordinary plywood or 4.8 hard flex board, the total of 4 times 8 ordinary plywood used on one side sheets is 10 feet. You have 19 feet for 4 times 8 ordinary plywood used two sides. And for our CW nails, 1 inch over one side, we have 0.6 kilo. And for our one nail for two-sided sides, 1.1 kilos. And for our two and one half CW nails, these studs together is 1.4 nails. So for our tiling, this is the quantity reference, and we enter the data. So we enter the floor area and the breakage of how many percent. It passes to 5 to 10%. So this is the quantity reference. We have 3 times 3 and so on and so forth. And the result, and this is the result for tiles. Number of pieces without, in this area without the breakage allowance, and in this area we have the breakage allowance. Now you can see the difference without and with breakage allowance. So the formula of this is we have and the floor area times the number of pieces per square meter, and you can get your number of pieces, and to get the breakage allowance we can times the 3. We have the 0.5% times the 5.3440 times yeah, to get the breakage allowance by 5%. So in order to change the percent, it's up to you guys. So for the painting, we have the quantity reference. Yes. And we input data input. 1 gallon is equals to 4 liters. So we enter the wall area coverage per gallon and no of quotes. And we get 2, and the wall area is 80, and the result, the number of gallons. Let's round up. Wall area over coverage times 37. Coverage over times no of quote, and we can get the 7.0 gallons in 80 square meters wall area. We used 7 gallons and applying 2 coats. So for drywall, this is our quantity reference. We have the lumber sizes and the spacing. So for studs, side of the wall and the sides of the wall B. We entered it in here, data input, total area of wall 7, the lumber size used, and the spacing in the center. And So this is used. So this is the one that used in the data input. 16 by 16, 2.3. And given spacing is 0.6 in meters. So for our result, we have vertical stud is equals to round up side of the wall A over given space and we have the result of the 16. In the horizontal studs, we have the side of the wall B and over given space of 0.6 and the result of 6. And the number of board feet of studs and nailing joint used, get to index D here what surgery has taught us. Yes, and we can get the product of 186.246 board feet, studs and nailing joint use. So thank you everyone for listening. Have a great day ahead.